So this is lesson 6, equations with decimal numbers, consecutive integer word problems in algebra 2. And one of the things that you'll notice here is the decimals. None of us like decimals. So we're going to do what we can to try to make the decimals go away. And that will make life a lot easier, I think, for everybody. So how do we do that? Well, first of all, we look at each one of the decimals that we have. We have this one, we have this one, and we have this one. And we look and see what number or how many digits to the right our decimals go. This one goes 3 digits to the right. 1, 2, 3. This one goes 1, and this one goes 1, 2. So this one goes the most to the right. That tells you how many zeros you're going to multiply the entire equation by. And when I say zeros, this is what I mean. That was a 3, so I'm going to put a parenthesis by the entire thing, and I'm going to put 3 zeros here and a 1 in front of it. So I'm going to multiply this by each of these, that 1,000, because this is 3, the biggest, or the one that has the most numbers to the right is 3. So 1,000 times 0.003 is 3. 1,000 times 4, or 0.4, is 400. And 1,000 times 2.05 is 2050. And then we just solve. 3x equals 1650. Divide by 3, divide by 3, x equals 550, and that's your answer. You do not have to go back and put the decimals back in or anything. That is the answer that we're looking for. So we're good to go there. Let's look at example 6.2. The students found that 0.015 of the teachers were either brave or completely fearless. If 300 teachers fell into one of those categories, how many were there in all? So, 300 were brave or fearless, and that was 0.015 of the teachers. So, 0.015 of the total number of teachers were fearless. And 0.015 of the total gives us, and it says there, that 300 fell into that category. So let's replace total with T for total, and just do our algebra. We're going to divide both sides by 0.015, like that. 300 divided by 0.015, and that gives us a total of 20,000 people. And out of that 20,000, 300 of them, or 0.015 of them, were fearless. All right, 6.3. Talking about an old lady. An analysis of the old woman's utterances, the things that she said, showed that 0.932 were vaticinal. The word vaticinal means prophetic. So she was prophesying about the future. All right, so 0.932 were vaticinal or prophetic. If she spoke 2,000 times, not all of those utterances were prophetic, but she spoke 2,000 times, 0.932 were prophetic. So we're going to take 0.932 times 2,000 to find out how many were prophetic. So when we do that, we get 1864 that were vaticinal. So they want to know how many were not vaticinal. So we take our 2,000, which is the total number of utterances, minus the 1864, and we get 136 that were not prophetic. And we're done there. All right, so let's look into consecutive integer word problems. Okay, so consecutive integers would be numbers like 1, 1 plus 1, 2, 3, 4, 5. So if we didn't know what the first one was, we might say that it was x. Well, the next number after x would be x plus 1. So if this were 3, we would take 3 plus 1 to get the next one. So this would be 3, this would be 4, this would be x plus 2. Well, 3 plus 2 is 3 plus 2 is 5. And the next one was 6. How did we get 6? X plus 3, or 3 plus 3, because we knew that our first number was x. So if we're talking about odd integers, and 1 is x, let's say that this number is 1. If we're talking odd, the next number is going to be x plus 2, because if this is 1 plus 2, that gives me 3, which is the next odd integer. The next one would be x plus 4, because we would have 1 plus 4, which equals 5. So see how we're going up. So odd integers, consecutive odd integers, will always be labeled this way. Even will be done the exact same way. The first number, let's say we start out with 2. The next one is x plus 2, which is 4. Next one is x plus 4, which is 6. So notice those are even too. So the expressions you use to show consecutive or consecutive even and consecutive odd are the same thing. So let's look at some examples here to get us started. If we have, it says in example 6.4, find 3 consecutive even integers. Well, let's write them down. 1, 2, 3. Those are my consecutive even integers. Such that 5 times the sum of the first and third. Okay, so the sum of the first and third, and it says we're going to take 5 times the sum of the first and third, is 16 greater than 9 times the second. Well, what is 9 times the second? 9 times x plus 2. And it's not only 9 times the second, this one over here is 16 greater. So I'm going to put the 16 over here like that. Then we just go ahead and do our math. 5 times 2x plus 4 equals 9x plus 18 plus 16. So that gives me 10x plus 20 equals 9x plus 34. I'm going to move this 9x over here, so I'm going to take it away. So that gives me x plus 20 equals 34. That doesn't look like a 4. Subtract 20, and my x equals 14. So there is my my x value. But that's not what they asked for. They asked for the 3 consecutive even integers. They asked for those. And if that's the case, we're going to put 14 in for x. We're going to put 14 in for x there. And we're going to put 14 in for x there. So we get 14, 16, and 18 as my consecutive even integers. And let's look at example number 5. Example 5 says find 4 consecutive integers. So it says consecutive integers. They're not even or not odd. They're one right after the other. So one is x plus 1, one is x plus 2, one is x plus 3. Such that 5 times the sum of the first and the fourth. The sum of the first and the fourth. So the sum of the first and the fourth, and it says, what about that? 5 times the sum of the first and the fourth is 1 greater than 8 times the third. It's 1 greater than that. And then I do my math here. I'm going to do what's in the parentheses. Distribute. 10x plus 15 equals 8. 8x plus 17. Subtract 8x, subtract 8x, so I have 2x plus 15 equals 17. Subtract 15, subtract 15, that goes away. Gives me 2x equals 17 minus 15 is 2. X equals 1. Now we have to take this 1 and put it back into each of those 4 so we get our 4 consecutive integers. So we get 1, 2, 3, 4. And that's it.